right, so in today's video, we're going to be going over the spring break Regents review assignment. At this point, you should have handed in your assignment already, but let's take a look at the first one. So the first one is talking about a parabola whose vertex is at 2, 1, and whose focus is at 2, -3. So if we were to graph this, we would have our 2 points, our vertex and our focus. Since the focus is below the vertex, we know that it's going to open down. So now we're going to use the equation 1/4p times x minus h squared plus k to figure out the equation of our parabola. hk is our vertex, and p is the distance from our focus to our vertex. So this is going to be 4, but since it's opening down, we want to substitute in a -4. So 1/4 times -4, and then we're plugging in our vertex hk. So we have -2 squared plus 1. So our answer is going to be -1/16 times x minus 2 squared plus 1. Okay, next one is talking about a local university has a current enrollment of 12,000 students. The enrollment is increasing continuously. So when we're increasing continuously, we're going to use this formula here. We have a rate of 2.5 each year, percent each year, and which of the following is equal to the number of years it will take to reach the population at 15,000. So 15,000 is going to represent A. Our P is going to be our current enrollment, our initial amount, which is 12,000. R is going to be 0.025. So at this point, we're just going to solve for T. So we're going to divide 12,000 on both sides. We get 1.25 is equal to E raised to the 0.025t. To get this t out to the front, we're going to ln both sides. Since we have the natural log, that cancels out. So we're left with 0.025t. And then if you divide by 0.025, that's what t is going to give you. It's going to be ln of 1.25 over 0.025. It's going to equal t. All right, next one. So next one is saying what is true about the graph. So let's just pull up the graph really quickly. Sorry, find my calculator. All right, so if we put this into the equation, into the calculator, we get negative log x plus 4. Let's see if we can see it nice in the calculator. Plus 2. All right, so as we can see, as x approaches -4, okay, so as x approaches -4, which is here, -4, f of x is, okay, so as we take a look at this graph is going to continue to go up to infinity. It's just not going to cross over that vertical asymptote. We're also going to see how if I was to solve for the y-intercept, f of x does not have a y-intercept at 0, 2, and negative f of x does not have a y-intercept of 0, 2. As x goes to positive infinity, f of x goes to negative infinity. So the correct answer is 4. All right, so taking a look at this one here, it wants to know the rate of change from 6,000 to 8,000, 9,000 to 12,000. So you basically just put this into the calculator and you look for the table. Okay, so we're going to put this in our calculator.
We are water.
Okay, that's weird. I've never seen that before. Okay. Oh, my window is, let's change our window. Let's start at 6,000 and let's go up by 1,000. Second graph. Okay. So at 6,000, we can see that it's going to be 17.3. At 8,000, it's going to be at 44.7. Okay, so that is 37.4 over 2,000. If we do 12,000, 83.3. And then if we get 9,000, 55.9. So that's 27.4 over 3,000. Okay, so therefore, if we're looking at our answer choices, the average rate of change is larger for 6,000. Okay. All right, next. Okay. All right, so the next one we have here is just using the quadratic formula. So when we use the quadratic formula, we want our A value of 4, B value of 0, C value of 98. We plug everything in, we get a negative value here. So if we simplify this, okay, so we can simplify this a little bit further here. So we can do the square root of 784. Sorry. Negative 784 times the square root of 2. And then the square root of negative 784 is going to be that 28i. And then bring down the radical 2. All of that over 8. And then we can simplify these here to be 7i radical 2 over 2. So number 4. Okay, so for this one, it's saying we have g of x. It's giving us that we want to graph from 0 to 10. We want to find the maximum. So let's go ahead and go back to our calculator. X to the 4th plus minus okay. So we want to look for the maximum value. So second trace maximum, left bound, enter, right bound, enter, enter, enter. We're about right here at 3.92. Right up here, 3.92. If we look over here, 3.92. They're about the same. Okay. Okay. All right. For the next one, Okay, so what we want to have here, we have fractional exponents. So we're going to distribute this exponent to each of the terms. So then we get negative 54 raised to the 2/3, x to the 9th raised to the 2/3 over y to the 4th raised to the 2/3. So fractional exponents can be rewritten as radicals. So we want the cubed root of negative 54 squared. Well, negative 54 squared is 108. So the cubed root of 108 can be broken down as the cubed root of 27 times the cubed root of 4, which is 9 times the cubed root of 4. This is going to be 9 times 2 divided by 3, which is x to the 6th. And then this one here is y to the 8/3. So this can be the cubed root of y to the 8th, which is going to be broken down as 2y squared times the cubed root of y squared. All right, so that is 9x to the 6th cubed root, and right here. Oh, nope, not that one. Right here, number 3. 9x squared cubed root of 4, y, and it's number 4, which is right here. 9x to the 6th cubed root of 4 over y squared times the cubed root of y squared. Perfect. All right, next one. So according to a pricing website, Android phones lose 58% of their cash over 1.5 years. So they're continuously losing their cash. Which expression can be used to estimate a $300 phone in 1.5 years? So what we're going to do is we're going to use our continuous formula. So if it's $300, that's how our initial amount, E, and then we're trying to find, we're losing 0.58 over the course of 15 years. So this is going to simplify to raise e to the negative 0.87. This here is 0.87. Okay. All right. Next one, we're looking for an even function. So if something is even, in order to maintain symmetry over the y-axis, you can only shift vertically. So inside the parentheses is a horizontal shift. So we're going to get rid of all of those. As you can see in my diagram, if f of x, let's say, was x squared, which is an even function, if we add 3, it will stay an even function because all we have is a vertical shift. Okay, next. What is the formula for the nth term? So in order to find that, we need to know our common ratio. So 18 divided by 54, which is 1/3. And then just plug into the explicit. So we get 4. Okay, next one. What does not terminate in the 4th quadrant? So if we're trying to find coterminal angles, because coterminal angles plus or minus 360 will tell us what quadrant those values lie in. So negative 300 plus 360 is going to equal 60, which is in quadrant 1. So it will not terminate in quadrant 4. All right, next one, we have an exponential equation. Notice I have a 3 as a base and a 9 as a base. So I'm going to do this by common base. So 9 can be turned into 3 squared. So now that they're common base, we just set the exponents equal to each other. Anything with a 2 is a quadratic, so we're going to set this equal to 0. We factor, we make our t-chart, and we get x is equal to negative 2 and 1. All right, now we have factoring by grouping. So I group the first 2, group the last 2. GCF of the first is x cubed. We're left with x minus 4. GCF of the second is 9x. We're left with x minus 4. Bring down what we have left, so x cubed minus 9x, and then inside the parentheses, x minus 4. This can get factored once again. Factor out an x. We're left with x times x squared minus 9 times x minus 4. This again can be factored. This is difference of two squares. So bring the x down. So it's x times x plus 3 times x minus 3 times x plus 4. So if you do the t-chart, you get x is equal to 0, -3, +3, and 4. All right, next one here. We're doing our inverse. So for our inverse, okay, we're going to switch our x and y. So f of x we know is y. So we need to make x equal to -3/4 y plus 2. We subtract 2 on both sides. And then we're getting y by itself, so we multiply by the reciprocal. And then I could distribute again, so -4/3 x plus 8/3 is going to equal y. All right, so you can do this one of two ways. I decided to use the remainder theorem. So what the remainder theorem says is to use the opposite, right? Because I'm looking for factors. So if I was to solve this, if this was a factor, x would equal 5. So if I substitute 5 into the function, if it's a factor, it'll give me 0. But since it's giving me 105, 105 is the remainder, which means that x minus 5 is not a function because we have a remainder other than 0. All right, next one is a 3 equations, 3 variable system, x, y, and z. So I used a and 2 times b to eliminate x. I got 7y minus 14z is equal to -7. I then did 4 times b plus c. So here we get -7y plus 21z is equal to 28. And then use these two to eliminate y and solve for z. Z is 3. So now that I have z is 3, I'm going to plug z into one of these to get y is 5. So now I have z is 3, y is 5. I'm going to take the easiest equation and plug both z and y in, and I get x is -2. So -2, 5, and 3. Okay, last one. Sarah's finding a sinus infection. She gets a nasal spray and antibiotic to fight off the infection. Here are the active ingredients. It can be modeled off of these two equations. Determine which drug is made with a greater initial amount of active ingredient. Justify your answer. So we want to know when t is equal to 0, okay, that's going to equal our initial value. So as we can see, 21/15 is less than 3. So the antibiotic has more active ingredient in the beginning. Okay, so now what we're going to do is we want to see when both medications will have the same amount of active ingredient. So we're going to set them equal to each other. So this is going to equal 9/t plus 3. So we're going to get common denominators. Okay, common denominators. So for this expression here, in order for these to be the same, I need to multiply this by t plus 3. And then on this side, I have to multiply by t plus 5. Now that they all have the same denominator, we can set them equal to each other. So t plus 3 times t plus 1 plus 18 equals 9 times t plus 5. We go ahead and we distribute. Again, I have this t squared, so it's a quadratic, which means I need this side to equal 0. So I move everything over to the other side. T squared minus 5t minus 24 equals 0. Well, that can get factored by t minus 8 times t plus 3. Do my t chart. T ends up equaling 8, and we're negating this -3 because time can never be negative. So after 8 hours, they will have the same amount of active ingredient. Okay? All right. If you have any questions, please ask your teacher.